Example 2. For each function, sketch its graph determine its intercepts and I just want to remind you here it's both x and y. We want to determine its domain and range. So for A, we have y equals the absolute value of 2x plus 1 squared minus 8, and B, y equals negative x squared minus 2. So the B part is y equals the absolute value of negative x squared minus 2. So here are the few steps for graphing absolute values of parabolas. So step 1, graph original parabola. Step 2, make all y values positive. Okay, so absolute value, the y portion, so it will be x, absolute value of y. That will be all your coordinate points. And step 3, connect the points. All right, so first things first, let's deal with A. And good glory, do I ever love copying and pasting. Da, 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 da. So we have here y equals 2x minus 1 squared minus 8. So the vertex is going to be at, oh sorry, I want positive 1, I don't want negative 1. At negative 1 comma negative 8, and we have a stretch factor of 2. So I'm going to place down my vertex first, negative 1 and negative 8. I'm going to create my parabola from there. I usually will go over 1, up 1. We have a stretch factor of 2 here. So I'm going to go over 1 and up 2. Boop, boop. And usually I would go over 2 and up 4, but I'm going to go over 2 and up 8. Boop. And a boop. And because I'm feeling particularly spicy today, we would usually go over 3 and up 9, but we're going to go over 3 and up 18. Whoa! Because 8 plus 10 is 18. That's how I know how that is, what that is so quickly. And I'm going to connect all of those lines. Or sorry, all of those dots. Whoop. And a whoop. So step 1, done. And I'm going to be very careful to label this graph here. I'm going to say this is y equals 2x plus 1 squared minus 8. Just so I know that it's not my final values. Now what I'm going to do is I'm going to label all my coordinate points here. So this right here is going to be negative 1 comma negative 8. This guy right here is going to be 0 comma negative 6. This guy right here is going to be negative 2 comma negative 6. This guy right here is going to be 1 comma 0. This right here is going to be negative 3 comma 0. And that's all I'm going to do for now. So in step 2, So this is step 1. So in preparation for step 2, what I'm going to do is I'm going to look at all those points. -3, 0, -2, -6, -1, -8, 0, -6, and 1, 0. What we're going to do now is we're going to make all the y values positive. So -3, 0 results in the same thing, -3, 0. And I want to just highlight this one too, because when I take the absolute value of 0, it's just 1, so 1, 0. These two are critical points. They're where the bump happens, or if I want to say it, maybe just a little more mathematical, I can say that the critical point is the x-intercept of the graph, and that's where the graph of y equals the absolute value of f of x changes direction. So we'll highlight that a little bit more. So if I'm trying to find the absolute value of the y values, this becomes -2, 6, because -6 becomes +6. I have -8, jumping the gun, -1, 8. This one becomes 0, 6. So what I want to do is I want to plot all of these new points to see what happens. I'm just going to do this in another color. I'm going to just use a little bit of a legend here. So my 0, -3, 0 becomes -3, 0. These two stay the same. Those are critical points. This one though, -2, 6 becomes -2, -6 becomes -2, +6. So 1, 2, 3, 4, 5, 6. Whoop. And 0, -6 becomes 0, +6. Whoop. And the middle one, -1, -8, this guy right here, becomes -1, +8. So if I were to connect all the points in step 3, I would say, go like this, whoop, whoop, and then do 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 do, psh, do 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 do, psh. And what I also, do you know what? I'm going to change my label here because it's a little bit confusing. I'm going to say that this right here is my y equals 2. And I'm going to say that this one right here, this middle section here, is my y equals the absolute value of 2x plus 1 squared minus 8. Because this portion right here only belongs to the absolute value, and this portion down here just belongs to the original. So we graphed it. It kind of looks like a bit of a weird graph, but we're talking about our critical points here. The critical point is when in the original graph it dips below the x-axis. Instead, in the absolute value function, it bumps up. Bumps up. So let's see what else we need to do. Determine its intercepts, both x and y, and its domain and range. So let's just set this up real nice here. So x-intercept. I'm just going to put that in brackets because sometimes they do. Hint, hint. The y-intercept, that's going to be singular. Domain and range. So for this function, our new function, the one in red, I'm going to say my x-intercepts are -3 and +1. So -3, 0. I'm going to change this because it looks like it's negative. I'm just going to put colon instead. And we have 1, 0. Our y-intercept, there's only one of them, is going to be at 0, 6. Our domain, just like with a parabola, is going to be x is an element of the reals. The range is a little bit different. Usually the range for this thing would be x is greater than and equal to -8. The only thing here is that it cannot be less than the absolute value function cannot be less than 0. So in this one, we're going to say y is greater than or equal to 0, and also y is an element of the reals. So it's a little bit different than finding the domain and range of the original parabola. When we're talking about the absolute value of a parabola, it can be greater than or equal to 0. Let's do the second one here. So we have y equals the absolute value of -x squared minus 2. Alright, so first things first, step 1, graph original. So my vertex, is going to be at 0, -2, and it opens down. No stretch factor. Okay, so I love this so much. Copy, paste, boop, 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 boop. So with my original, my vertex is going to be at 0, -2. And we're opening down. There's no stretch factor. Over 1, down 1. Over 1, down 1. Go back to the original. Over 2, down 4. 1, 2, 3, 4. Over 2, down 4. And I would love to go over 3, down 9, but we're already at 2 and it only gives to 10, so we're just going to stick there. Open, go like this, and go like this. Now my graph is a little bit off here, right, because it should be here, but I remembered my arrowheads. Woohoo! Step 2, all y values must be made positive. So I'm just going to identify the points that we have here. So right here I have -2, -6. Here I have -1, -3. Here I have 0, -2. Here I have 1, -3. Here I have 2, -6. So when I when I find the absolute value of all of the y values, that results in -2, 6. -1, 3. Now I just want to make note, you can have negative x values. That's not what we're getting at here. We just can't have negative y values. 0, 2. 1, 3. And we have 2, 6. Alright, so I'm going to draw this in red, just to be consistent. So I'm going to plot these points here. I have -2, 6. I have -1, 3. I have 0, 2. I have 1, 3. And I have 2, 6. Alright, awesome. So this one right here I'm going to label, make sure that I know that this is my final one. Y equals the absolute value of -x squared minus 2. And this guy right here is y equals -x squared minus 2, not the absolute value function. Now sometimes your absolute values are just going to be all positive. Okay, say and say something like this opened up, the absolute value and the original graph could look the same. But this one right here is all positive and it looks like a normal parabola. Sometimes we're going to have a little bit of a bumpy time. So you go, looks like a normal parabola, then boop, bumps up to the vertex, boo, and then goes up to where the normal parabola would have been, or the original parabola would have been. So you're going to have two different shapes. You're going to have something that looks like this, kind of like a bump up. That's when the vertex is below. Okay. You can also have a and you can also have this one right here where everything looks normal, even though it is different than the original. Let's just finish off the question by identifying the x-intercepts, the y-intercepts, the domain, and the range. So we're just discussing the absolute value function parabola here. So we're noticing that there are none. So we would just say no, none. That's because it doesn't touch the it doesn't touch the x-axis at all. The y-intercept here is going to be at 0, 2. The domain for this thing, it extends into infinity in both directions. So we can say that x is an element of the reals. And in this one, it isn't just x is greater than 0. Okay, for this one, it's x is greater than 0 because everything had to be above the x-axis. However, in the absolute value of this, the vertex is above. So we can say more than just y is greater than 0. We can say that y is greater than or equal to 2, and y is an element of the reals. So this one, essentially with domain and range, just look at the actual resultant graph and you'll be able to figure it out.